High above the Pacific in October, when the northern hemisphere tilts toward winter, a small gray-brown bird no heavier than a teacup launches itself from the mudflats of Alaska and begins a journey that defies everything we thought possible about animal endurance. Bar-tailed godwits, Limosa laponica boweri, undertake the longest nonstop migration on Earth, 12,200 kilometers from Alaska to New Zealand in a single unbroken flight that lasts 8 to 11 days. Satellite tags confirm one female, known only as 234531, flew 13,560 kilometers in October 2024 without a single stop, the longest verified animal movement ever recorded. These birds prepare for the impossible by performing biological miracles in the weeks before departure. In late summer on the Yukon-Kuskokwim Delta, they deliberately double their body weight, transforming from 250 grams to over 600 grams in just 3 weeks. Fat becomes fuel. Up to 55% of their total mass is pure lipid, stored beneath the skin, around organs, and even inside hollow bones. Their digestive system shrinks dramatically. Stomach and gizzard atrophy by 60%. Intestines shorten. Liver reduces in size. Every gram saved is a gram of extra flight distance. Then, on a clear autumn evening, they take off into the jet stream. Heart rates climb to 700 beats per minute. Wings beat 12 times per second for the first few hours, then settle into a steady rhythm. GPS data shows they fly at altitudes between 2,000 and 5,000 meters, riding tailwinds that can exceed 100 kilometers per hour. They never land, never drink, never eat. Sleep happens in microbursts of seconds while one brain hemisphere shuts down at a time, a trick called unihemispheric slow-wave sleep, previously known only in marine mammals. Navigation remains one of ornithology's greatest unsolved puzzles. Bar-tailed godwits possess an internal magnetic compass calibrated by the Earth's geomagnetic field, a sun compass that adjusts for time of day, and star pattern recognition for night flight. Recent studies reveal magnetite crystals in their brains and beaks that function like biological GPS sensors. They correct for wind drift with astonishing precision, maintaining a straight-line course across featureless ocean with deviations of less than 1%. Mid-flight physiology pushes the limits of vertebrate survival. Blood oxygen levels drop to near critical thresholds. Dehydration becomes extreme. They lose up to 30% of body water, yet never show signs of kidney failure. Muscle protein is carefully spared. Instead, they metabolize fat so efficiently that waste products remain minimal. When they finally collapse onto New Zealand mudflats 11 days later, they have burned every spare gram of fuel. Their flight muscles have shrunk by half. Legs are stick-thin, but within hours they begin feeding on tiny shellfish and worms, rebuilding organs that literally dissolved en route. Climate change now threatens this marathon. Rising sea levels drown Alaskan breeding grounds. Warming oceans shift prey availability and wintering sites. Stronger storms knock migrating flocks off course into exhaustion. Yet, the godwits adapt. Satellite-tracked individuals have begun taking slightly longer southern routes to avoid headwinds, adding distance but increasing survival odds. What makes the bar-tailed godwit extraordinary is not speed or strength, but efficiency perfected over millions of years. While humans require machines to cross oceans, this bird does it on stored body fat and an internal map written in starlight and magnetism. Every October, thousands launch into the void, carrying nothing but themselves, proving that the greatest journeys sometimes belong to the smallest creatures. In a world where everything seems to demand more energy, the Godwit reminds us that true endurance is measured not in power, but in how perfectly life can be reduced to the essentials of flight.